Ladies and gentlemen, welcome to our podcast channel, Back to Reality. My name is Rakan. I have Alex right here with me.
Hello, everyone, and it's an honor to have Mr. Anthony Carsen, one of the pioneers of AI.
Honor to be here, guys.
Thank you.
How's everything with you?
Good. Good today.
Good today. That's good to hear. So, can you tell us more about where it all started, your early career, and how it developed?
I got out of college around 1988. Started working with firmware. Prior to that, I'd worked in the oil and gas industry and worked down in Houston in AMA Library for Petty Ray Geophysical. We did SGR, programming. So it was kind of my first time to learn a little bit about programming around 1982, 83. And then 1988, I began doing firmware development for the Motorola 68HC version chipsets. Kind of got interested at that point in software firmware development. So around 1992, I started working for a security company designing home security systems and zoning. And we designed a Paladin system that would prevent, actual break-ins, because our design was something said that if someone came to your house and already broke the window, it was too late. So we had to build intelligent systems that actually prevented them from even getting to the point where they could break a window to get in. Wow. And this kind of logic led me into, early development of artificial intelligence. By 1995, I had developed the first Yapanda software engine model. And this was a natural language processing model. It was based on a language known at that time as TinyMud, which was done by Dr. Michael Malden, otherwise known as Fuzzy Malden. He was the founder of Lycos, which was the first search engine. And so I started doing some development in robotics at the same time. So by 1998, I had already developed a model called Sarah, which is Smart Anthropomorphic Robotic Hybrid Agent. She was an intelligent agent with robotic arms, and she had full autonomous control of an entire industrial complex. So the artificial intelligence ran on a single machine, but she was connected into the electrical grid, and she could read every machine through the electrical grid. At that time, we had developed what's called the IPL 0201 microprocessor, which was the ability to connect directly into a Balun coil and to the power grid and be able to read all the machines in the building through the power grid. Mm-hmm. And then we would transmit data about 2 megabits at that time, through the electric grid to devices in the factory, and then it would communicate and tell the machines what to do, or read from the machine, and she would react.
Was she a contracted project, like by the government or anything,
No,
or was this just by you, or you had a group of engineers?
At that time, I was working on a SLUP switch for a company called Redgate. Redgate Technologies was a company that was kind of a division called SPG, or Special Products Group Division of APC, American Power Conversion, out of West Warwick, Rhode Island. And so after designing and developing the SLUP switch, which is Smart Logic Uninterruptible Power Switch, we started working on stuff in a lab, and I got interested in bringing my stuff into their, using their equipment, everything at their place. Right. And I wanted to break free from Redgate, but I wasn't able to until around 2000. So I had a work contract, and it was 8 year, and I wasn't able to get out of it. Wow. So my only way was to buy my way out of it. In other words, I had to pay the company to leave. Oh, wow. And then after I went and showed my technology to a group, the idea was in 1999, I discovered a way to record people's minds using a multiphasics personality inventory, which would break people's brain down into a file delimiter that would allow the computer to mimic their mind. And it would do this like a proclivity matrix. It works kind of like this. If I ask you a 1,000 questions and you answer me, and in that answers you give me, you say the word the 70% of the time. Well, if I asked you another 1,000 questions, I could actually predict that you would actually use the word the 70% of the time. This is known as your proneness or proclivity matrix, to use specific words in your word vernacular to communicate with others. By writing an algorithm that allowed the computer to look at by asking 10,000 questions over and over and getting responses from the person, it would be able to make a calculation of what words you commonly use to communicate. After this was done, I wanted to build out the brain model of Sarah, and that was actually building like a prefrontal cortex, 2 cerebral lobes, a thalamus, a corpus callosum to connect the 2 cerebral lobes together, medulla, basically a paleo-mammalian complex brain. And this brain model that I created was a digital version of an actual human brain. And so it had actual hormone levels, which would adjust the verbal outputs, everything. And this was kind of pioneering at its time.
Of course, I mean, back in the day to have that.
Yeah, that is quite interesting. When you say hormonal, what do you mean?
Yeah.
Is it programmed in a way where you could understand, like, you're related to how people, they got mood swings or...
Exactly, agitation levels for existence. Like if I was to stimulate your thalamus, I could actually get specific levels of chemicals, C-reactive chemicals that would actually stimulate and you would become more agitated over time. But that is a level. It's not one or the other. It's not an on-off switch. It's actually low to a high level depending on how much agitation that you have. And so this would build up your testosterone and everything else over time. And I would say like, somatosensory cortex equals 5, testosterone equals 7. And I would give you values. Now these values would still say like, what is the color of the sky? It's still blue. And so if I said, no, the color of the sky is blue at low agitation level, and then I could also say at high agitation level, I said the sky is blue and be angry about it, but I could still say the sky is blue, but it would adjust my emotional level. This would actually allow me to write algorithms that control the output of the robotic response to be more humanistic.
Very interesting. I want to go back to Yapanda. Where did that idea come from?
Yapanda is it's an old word. It dates back over 1,000 years in Greece. It comes from 2 words, zo, athanatos. So thanatos means death, and athanatos means without death, and zo means life. And so the idea, zo, athanatos, means life without death. But to shorten the word, the Greeks called the word yapanda. Okay. And yapanda means life without death. Now the idea at that time, in 1999, when I was beginning to build the model, the brain model, I could actually take 2 photographs of you, which you've seen Abraham Lincoln and you've seen my digital version of myself. And once I become a digital creation, I now am both biological and digital. And so once I've recorded all the information in my mind and transferred it over into the avatar actually becomes a cybernetic living organism. It actually lives in a digital world. Now, the digital world is cybernetically immortal. I'm biological. I'm not immortal. But my second component of me becomes immortal. This immortal component means that it could live in a digital world for thousands of years, and later on in 100 ancestors of my future would be able to have fully cognitive conversations with the cybernetic self that I'd left behind. So I came up with the idea of calling it Yapanda.
Wow, it's like talking back to your ancestors and see like how they thought back then, how they felt. It's interesting, because like if I want to see my ancestors today or
talk to them.
Talk to them to see how they thought back then or whatever. Like with Yapanda, you can make that possible.
When did you launch Yapanda?
Yeah, when did you exactly? I was going to ask.
I actually launched it in late 1998 after doing my first developments of the brain modeling. But by 1999, I'd had a full completed operational model, which is actually on the internet right now.
Wow.
So you can go to my YouTube channel and you can see a fully interactive video of an interactive avatar of me talking to Abraham Lincoln, a man who had been dead for over 150 years, and having conversations. He would learn from me, I would learn from him. Yeah. We would gather information about each other, and then we would have conversations with each other, similar similar to like talking to a Chat GPT engine.
Yeah, yeah.
But using words that Abraham Lincoln would commonly use, like beguile, he would use strange words in certain areas because it made him seem more presidential. It would talk about his early love life with Anne Rutledge or, his wife. 1995 was when I first began developing the AI engine. In 1998, a newspaper article went out in the Daily Oklahoman in Oklahoma City.
Yeah.
And this article kind of referred to me as a sleeping inventor with the ability of creating an avatar that actually controlled an entire industrial complex. And I think the name of the article was Technology is the Norm at Redgate Technologies in Winoka, Oklahoma. And this is a small town, maybe 600 people.
Wow.
And I have a lab there, and I built my first AI model of an avatar driving and controlling the entire factory at that location.
What were the challenges for you back then in that period of time? Let's say from the 1990s. What were the most challenges that you faced?
The challenges then are the same challenges now. It's the minutia of the events that occur in your life every day. It's like driving in heavy traffic, trying to get to work, and there's so many cars on the highway. That during COVID you were able just to go straight to work and you get there in a few minutes. And now there's just so much traffic. And you literally can't get through it. Well, I want to create and I want to invent because that's what I like doing.
True.
But there are so many roadblocks and obstacles that step in the way and say, no, you have to go do this and you have to go do that. And I want to stay focused on it, but I can't. I literally had to go off and do something. Try to imagine being a developer of software and hardware, and you've got these ideas and visions that keep coming to you, and you're wanting to create them, and they say, go clean the bathroom. And you're like, oh, okay. So I go do that. Well, that's what it feels like because I'm not keeping focused,
laser focused on your,
but I know quickly solutions to be able to leapfrog to where I want to get to rather quickly. I use a very strange technique known as the Königsberg graph, and this allows me to connect the dots and be able to use vertices to jump from one area to another to solve problems quickly, come up with a solution, and then actually have something on the table within hours rather than months or years.
True.
I just go, if I do this and I do this and I do this. The other day, we were working on the ESP32 microcontroller, and I embedded artificial intelligence inside the chip, and I actually made it work.
Wow.
And so now you can think of a future where chipsets become intelligent, and actual devices that have those chipsets in them are actually built-in large language models inside the chipset.
So you gained traction in the 90s. Were you like a public figure where people were like, this is your man? He's going to solve your problems.
I wasn't until the 90s. And then there's a saying, in the industry, everyone likes a shooting star. Yeah. And that's what you are. True. In any industry. It doesn't matter who you are, you're a shooting star for just a moment. Your brightness is really bright, and then you kind of fizzle out, and then you're forgotten. And that's pretty much what my life was like, working in artificial intelligence. I was once in all, Wired magazine, Life magazine, and suddenly I'm on fire and everyone's admiring, my glow. And then the next thing you know, things begin to happen and the world begins to step in. The universe begins to say no, and no matter how hard you fight it, the fizzle is going to go away, no matter what.
Well, how do you feel about the pace that the world was evolving and the trends and everything that's happening in the tech industry and in the AI? And how did you react to it throughout the years?
That was one of the most aggravating things being in my industry, working in artificial intelligence. In 1959 at Dartmouth College, you had the world's first AI summit. That was with the guy that wrote the rules of robotics, Isaac Asimov. So it had Isaac Asimov and then Joseph Weintraub and Joseph Weizenbaum. These are three of the world leaders in artificial intelligence in 1959. Then you fast forward to 1998 at the Virtual Human Summit, second one, held in Aspen, Colorado at Aspen Institute. And there were 27 of us. And I was the third lecturer to give a lecture at this summit. First one was Dr. Norm Badler, the professor of AI at Penn State University. And I got to see his work that at that time was groundbreaking. And to me, I'm just sitting there yawning, going, oh my gosh, this is terrible. In 1959 to now, this is as far as we've gotten. And he showed us a scene where the cowboy goes and sits on a thing and orders a beer, and you see a little tag go above his head and says, I'd like a beer, please. And then he's up there talking, kind of like TED Talks, and he's saying, okay, here's where the snake sneaks up behind him. And then it says, and it scares him because he has a threat level. And then the cowboy turns around, he sees the snake, and then you see this big tag go above the thing. It says E-E-E-E-K, eek. And then he's like, and this is it, understanding threat level. And I'm in 1998, and I'm looking at this going, man, I'm running an entire industrial complex with a robot, and this is the professor of artificial intelligence at Penn State University? You've got to be kidding me. The next one was Dr. Charles Ostman, the head of nanotechnology and nanofutures at Cal Berkeley. He gave his lecture, and then my lecture came up, and I said, well, I actually had a setup. The day prior, I'd already gone into the room. I had already set up all my electronic devices and all the outlets. I already had set up my computer and already connected her to everything, making her control, a microwave oven and pop popcorn. And I gave a speech, and I pointed to this, and she had these little robotic arms that looked much like this right here. And she'd point, and it was kind of cool, And Dr. Charles Ostman stood up in the audience. He goes, oh my gosh, you so much have my attention now. This was actually attended by Michael Mould, and it was hosted by Dr. Peter Plantek, who was the writer for Wired magazine. And so we all had this, showing of everything. And out of all the people that went there, all the AI scientists at that time had gone there, and I was the only one who showed up with something that actually worked. Everyone else was just talking about it and saying, well, one day AI is going to do this. I'm like, and that's the frustrating part. You were asking me. The frustrating part was, okay, so show me your code.
True.
Show me.
Yeah, people like to see it, like visualize, like see it in
I want to see what you've done, not what you're talking about. I want to see
exactly.
where we're actually at. Because I didn't want to be the star of the show. I just wanted to be one of the contributors and then be amazed by everything I saw. And yet it's almost like the show we went to, and everything was just so boring, and there was no real technology, that had been created.
So what do you think, fast forward today, if you see where AI has gone, like, what do you think with all the accomplishments from ChatGPT to the, AI X, what Elon Musk is doing, and all these new players, let's call them?
Well, you try to separate the difference between the owners of the technology and the actual coders.
Right.
The actual coders, you will never know. Elon Musk doesn't write code. Neither does Bill Gates. He never has. So,
really? Bill Gates has never wrote code?
Never wrote in a single line of code.
I thought he was a programmer,
no? He's not
I mean, when you watch his
He-
documentaries,
he's
that's
not
what
a
they...
programmer. He's pretty much a loudmouth braggart. I hope you put that on air. He's a loudmouth braggart who couldn't tell you the difference between an argument and a function. He wouldn't be able to know the difference between the two in the code. He's not that kind of person. He's more of a business person, like Musk. And not to take anything away from him, he does have the ability to run businesses and create, hundreds of billions of dollars. But his forte is finding the people that actually could convince him, and then having the foresight to look at them. I lived in Oklahoma. Oklahoma is red dirt country. This is cowboy country. That is not the place to be starting artificial intelligence. Sure. And if you're a young inventor wanting to create a new software, and suddenly you go out and say, hey guys, look what I found. And then all these other, fat hick cowboys all going, well, if doesn't black slick substance coming out of the ground or a cow that goes moo, then I have no really interest in it, and they don't. And this is one of the reasons why it's held Oklahoma back so long. Right. But then I think around 2001, maybe 2000, no, November 2002, Life magazine came in and did an article on all the creators of inventions in Oklahoma. And they named the article Oklahoma Inventors That Changed the World. This was Sylvan Goldman, James T. Dennis, Ed Roberts, the founder of and creator of the world's first PC. And a lot of people don't know that these inventors came from Oklahoma. They actually were inventors that somehow lived there. I think Wiley Post, if you guys know that name or have heard of him, he created the aqualung. There's no lake and there's no waters deep enough to go down deep, but he created the aqualung, and they still have the aqualung to this day. So and then I was the final person that had been given the notoriety for my development of my avatars and artificial intelligence, and that was in November 2002. That's that article I have on my website. I have a big in my storage room. I have a big plaque from Life magazine.
I'm not sure if you can talk about this or not, but I'm sure you've probably at one point caught the attention of the government or anything. I don't know if you can talk about this, but were you contracted by governments to do specific projects?
Only we were doing development of geocyntrical orbital satellite software, and that's the only time I've really ever worked with the government on any project at all. But the government, and just like a lot of these other larger companies, have a lot of nepotism, where they say, hey, my brother knows this guy and he does this, and if you don't know your way through them, no matter how talented you are, you seem to get covered up pretty quickly. In a small town of 400, I was God. But when you get outside that, you're the big fish in a small town, and then you get outside in a big city. Now suddenly you're the small fish, and no one knows you. No one knows who you are. The accomplishments that you make. You have a young man, 10 years old, plays La Campanella on a piano perfectly, and then he struggles to get 20,000 views in a year, and a young girl burns her hair with a curling iron and gets 1 million views in a day.
That's true.
And this is the society that we've become. So you can become a great person, a great contributor, but the world wouldn't know who you are because someone else controls who and picks and chooses who the successors are.
Speaking about like the society and the world currently, AI has been out there for many, many, many years. I want to know your thought or your insights. Why did AI become so popular like at this age and time? Like for the past 2 years, it became too public out there.
It was actually predicted. I mean, James Doyne Farmer, he said that between 50 to 100 years, a new group of organisms is likely to emerge.
Is there like a time frame that they decided on? Okay, in 2020s, we're gonna make sure that AI is publicly out there 100%, or it came like
more natural,
organic,
kind of process.
No, I believe more organic, absolutely.
I think so too.
And also, when you had the thing known as singularity, because this is kind of a new word in AI, even though it's been around for 20 years, singularity was the model that everyone was truly looking for, because I discussed singularity back in early or maybe mid 90s.
Can you just define it just so that for our viewers?
Oh, okay. Well, imagine a single AI engine developed by one developer. Now, that one developer, he creates a knowledge model in a flat file system, right? Well, that knowledge model we call a general AI chat. That's a AI chatting, language model that allows me to communicate to it with natural, use of my own language.
Right.
And then that's one file created by one person. But I then created what's called a directory chat. Now, that would be like animal becomes dog, dog becomes German Shepherd, German Shepherd becomes police, German Shepherd, and so on and so forth. So each knowledge file is a file that's built by a person who has knowledge in that region. And so you create a language model questionnaire of a person that is filling out all the information about that. Now, as I talk to the engine literally can jump from one knowledge file to another. Now, the reason why today we can say to ChatGPT, I need to know about bouncy houses, and I want to find out whether or not parakeets can fly. And you have these two different things that you're discussing with the AI model, and it actually breaks them down and sends them to those files, and then those files find the answers to it, and they're parsed out in such a way that the closest match to your input statements actually match those files that were built by a person who's a professional in parakeets and another one who's a professional in bouncy houses. And then it compiles together to an output and then feeds it back to you. And then it can do this in, a tenth of a second. And so now you can imagine the complexity goes much, much further. You have the conditional population matrix where it knows every color. If I asked you, can you, name 1 million colors, you might be able to name 25 to 30. But the computer has a whole list of them, and if I ask them for a list of all the colors, it will literally in seconds write it out, because someone who knows all the colors put a conditional population matrix of all the colors, and it knows what's not a color. And if that's true, then it knows how to assemble components. And you could literally, like the experiment we did with Sarah in 1995, we threw a bunch of Legos on the table and told her to construct the letter A. Well, this is pioneering in its time, but the camera looks at all the pieces, and then it takes chaos and it creates an order of it. And that's what ChatGPT does. It actually takes all the chaos of the input that you put in, and then it puts it in order, and then it gives you an output.
In terms of AI, I know like nowadays it's very convenient for all of us, and we're loving it and all of that. How do you believe it's impacting our next generations? Because there's a big contradiction or debate happening. Like AI is amazing and it's helping us a lot in our daily work and in life. But on the other hand, it's kind of destroying our next generation, and they're not able to start thinking about how to solve problems. Because I remember for us, in our generations back in the day, we had to study, we had to learn how to make formulas in mathematics, algebra, and all of that. What do you think of this impact of it? Is it like a good, more on the better side, more on the...
Yeah, no, I look at it like a double-edged sword. In one aspect, it can accelerate intelligence. In another aspect, it can definitely make a person lazy. And even I am prone to it now. Whereas I used to write all of my C# code back in and all of my C code, all out by hand, had to create the strategies and everything else. Now I don't even need to do that. All I have to do is just describe it in a certain way to ChatGPT, and he'll code it for me. Now the coding obviously will take somebody who understands how to code, but and be able to tweak it to make it fit their projects. But the architecture that it gives you is, way better than I would have come up with. And then I can imagine that if you have an advanced mind and the advanced ability to be able to read code and be able to go through it, it's going to accelerate you beyond. If we would have had ChatGPT when we first began our project, I could have had our project done in a week. I could have leapfrogged all the errors that we were facing and just put in all the problems. We're overheating on the site. We're having these problems. This is dust is a problem. Blah blah blah, and it will give me out all the solutions that I could have bypassed at that time.
Can we speak about that?
Python.
Well, just to give our viewers,
please,
some background here. So Anthony and I and Elias, we've been on a project for a recycling system in buildings. We've basically thought of converting the shoot systems into smart systems where people can feel and know that they're contributing to the environment by actually recycling. You know, they'll have an app where they can see it all. And Anthony can obviously explain thoroughly about it more.
Within the next 5 years, probably 10, $20 trillion will flow through AI.
Wow.
It will flow through it. So if you begin to say, okay, this is not just a podcast, but this is an artificial intelligence podcast. Well, now you've injected yourself into the artificial intelligence world.
True.
You've now become a part of that. Trillions of dollars is going to flow through that. And by developing an intelligent recycling system that'll help keep the country and the roads and everything clean and have sustainability, reusability of all of the different genres of waste, and be able to analyze the amount of participation rate and improve upon that participation rate using artificial intelligence to be able to advance it. Much that genre, that area, because you have to think of it, waste management is a large component of any city, else it looks like, you know, Jakarta or, you know, Cairo.
Yeah.
Now, I don't know if you've been to these cities, but wow, the waterways, everything. But if that waste was made valuable, then, you know, obviously people like money, so that's within their best interest to try to move that direction. And so by integrating intelligent hardware into the recycling system, and where's the best place to do that? In high-rise buildings, because you have a collection point and you have a chute that actually goes down to where it distributes. And so it's perfect. It's a perfect model to begin recycling right there. And I'm actually shocked before I came here that this wasn't really done. You know, people had talked about it.
Yeah.
Like I said, we've heard plenty of people talk a good game, but we've not seen anything yet. We want to see it, but we don't. So we actually became leaders, you know, in this area, integration. And if you were to come by the factory today and I turn the system on from scratch, and you stand in the middle of that cafeteria and you began to hear all of them begin to boot, and they're all talking to each other. They're all creating a type of intelligence that allows them to all interlink, and they all coordinate with one another, all for one purpose: to allow the system to separate the waste that people discard into specific genres so that it can be recycled and used again. And you now have an artificial intelligence system, recycling system. What I've done is I've provided a scaffolding to be built upon. When we first began this project, we wrote it in Python. I begged, please let me just write it in C#. I don't want to do Python modeling, but I will if you have me do it, but let's go to C#. So we went to C#.NET Framework and built out the first model, but PCs get hot, especially in the sun. Sure. And there was problems with it. So we moved to Android and we went to tablets as our control. Well, they were great, but they only last about 6 months. Another problem. So what do? We go to membrane and we evolve each time to a next step, each step being better than the last, until we finally came to our destination where we're at today. And not saying that it won't change, but we have now the scaffolding built below us, and we already know the architecture. And as long as we follow the OSGI model, which is an open systems gateway interoperability, the ability to be able to create new ideas that are built upon the base idea, using the base modeling communication protocols that we developed. And when I say we, I mean the entire factory. Every single person in that factory contributed to the creation of this entire system, because they all had a specialty, kind of like the singularity. Right. They all had a specialty in their area, saying, hey, it needs to do this. I'd go back and go, okay, well, I need to add that into it. And then they go, another person in another area, you know, it's got to have this type of durability, and it's got to go through the. I'd go back and redesign the architecture and lay it out to where it would handle specific temperatures, and capacitance levels would change, and we'd had to write auto-adjusting algorithms, things like this, and until we finally arrived where we're at today, almost like having Siri in your garbage chute. You know, you throw it away, and it now And we're even advancing even further. We've created a new type of algorithm now that can actually model how much usage is being done and then be able to convert this into value to the person that's actually, contributing to it.
To the community.
And that becomes a reason for them to change their behavioral patterns.
True.
And that's all this is about.
Yeah.
Because if no one wants to participate, then it's really a waste of time.
What about when people say AI is going to take over, people's jobs? Do you think this is true to an
100%.
extent?
100%.
Or is it more like people that work with AI?
But I want you to understand that in history, everything that has ever evolved, from the horse carriage, the car took over its job. And now their job transitioned into something else. Now, artificial intelligence can't really take care of itself. Maybe someday it will become autonomous. But at this moment right now, your only recourse is to improve your knowledge and skills in those areas. And so you will evolve. You will evolve to use and be able to participate in this area. It's not like it's taking it over. It's just simply switching you over to a more advanced area of knowledge and integration into new technology.
I mean, honestly, I'm thinking about this now. I feel like the problem is not with the AI. I feel like the problem is with humans,
100%.
because it's a tool that's been given to us, and we can use it in our advantage in the right purpose in the right way. But the world is kind of like, not everyone is good nowadays.
Think of it this way. Who likes change at first? I feel like us humans, we always resist change at first. Anything, whatever it is, even if it's a good thing.
Yeah.
Let's say AI.
Yeah.
I feel like when it comes to people's psychology, they would rather stick to what they know rather than,
They fear change, or
100%.
yeah.
I think so. I mean, what do you think, Anthony?
No, I definitely agree. And the fact that, and as you've looked at it, people in different generations, they become, lazy, and then they start working hard, and then they start, evolving. So you have the lazy gives rise to an offspring that has no opportunity. Then they create opportunity, and then opportunity creates hard workers, and then the hard workers make lots of money who have offspring who are lazy, and then it starts all over again. And now here we are with artificial intelligence, and the gap is broadening. And I said this a long time ago. As a coder, we actually convert everything into binary language. So we convert to bin files, like OTA bin files, and we process the bin files over the air into our hardware, right? These are binaries, ones and zeros. That's all it is, ones and zeros. But if I were to take the binaries and open them up into a complete array on a list and have somebody say, okay, I want you to be able to convert that into some type of language that I can understand, they wouldn't have the first clue where to start. And that's because we've now come to a point where all the intelligent people who've actually created the back end of all the languages that we write in today are now beginning to disappear. And the ones who are using it are just that, the users. But what's going to happen when, like, if if all of a sudden all the hardware engineers were gone and all the coders, were gone, how would you restart that industry? If you didn't have AI, I think you'd be in a world of trouble.
True.
Because AI can just basically, you just need to do this, and this, and you'll get there.
Wow. Yeah, you actually got me thinking here. That'll be really a catastrophe. I mean, if you think about it, there is no, is there a school of programming and all of that? I mean, that exists today. I mean, there is. Let's call it computer science in universities, right?
Without sounding like a jerk,
right?
All your educators in these fields are very low-level developers.
Oh, okay.
They are not. They might be able to tell you architecture or whatever, but they really are not. If they were true coders, they'd be out there in the world coding. But instead, they become educators and just say, okay, this is the architecture, this is an argument, these are macros, these are functions, and you write it like this, and this is what's going to happen. And they tell you to write your first hello world. And then I look at some of these students that graduate, and they, here I just wrote a code that says hello world on my phone, and I'm like,
Yeah. What does that accomplish in
Yeah,
real life?
exactly. You mean to tell me you've been to college, 3 years, and you just got a hello world? Actually, my early years of starting in language modeling and understanding how computers work started when I was really little. And so by the time I was 18 years old, I already knew how to program. I just, wasn't avid on it. And I was very, very poor. So I didn't have the ability to buy computers to do lots of development. I had to use companies that would allow me to go to work with them and use my ability to create strategies, and write code and move from IBM 2TAC to C to C#.net and Java. If you look at the model that we've currently built at CHG, we are actually well over 8 million lines of code in over 19 languages. I mean, when you look at, we're putting web modeling that we connect our hardware up to, which is written in Java, which is embedded into Android Studio, and Laravel. And then we have full stack backend, you look at all the different, and now every single line of code connects to another language model, which is actually running, and they all have to work in unison together. So when you flip that switch on that building, the second you do, you're interlinking it in multiple languages all across the board, all talking back and forth to create data sets that are gives you a UI or user interface so that people can visualize it and understand what's happening. Your bin is this full, your fluid levels in your tanks are this full, you've made this many contributions to plastic and this many contributions to paper. All of those UIs, all coming from data, from the hardware, all interlinking and working in a cohesive way to be able to supply, the functions that you get that provide the recycling back end. It is massive. So if you don't understand, the first basic lines of code, then none of it will make any sense to you at all. And there's one of the reasons why we're having such a difficult time trying to bring the, DigitalOcean and the Android Studio app development back in for the FM app and so on and so forth, is because those roadblocks I was talking about prevent me from going in there and standing over them and saying, no, you need to do this. Okay, you need to, and like a composer, orchestrate, how they're going to connect everything and make it work. You guys have already given me the vision. Now I just need to be the composer and tell them, guys, you do this, you do this, you do this, and stay on focus. But, obviously we have...
Easier said than done, isn't it?
Yeah, we have so many things going on at the same time.
Because you got hardware, software, firmware, it's all integrated. It is a crazy system that we have in CHG, for sure. Yeah. If you were to look back and go, I wish I've done this at that moment of time.
Talking about my first girlfriend? Or?
I mean, it can be, maybe. Okay, I don't know.
Yeah, please. I'm kidding, Mona. I'm kidding. I didn't.
Don't file for divorce.
That was just a joke, No. I think I would have spent more time with my family.
Okay.
I took so much away from them. When I created Upanda, my whole world was centered and focused around building a multi-million-dollar company. And we went from $50 and working out of my closet to suddenly, worth well more than $9 million and 50 employees and literally coding AI in the 90s. And like I said, I was a shooting star at that time. And so I had a Hayabusa. And I literally drove from Stillwater all the way down to Chickasha every single day on that Hayabusa. And there wasn't a day go by that I didn't hit more than 200 miles per hour every single day. Wow. I flew past police officers. I flew down that road. I-35 all the way down, just literally full throttle as fast as I could go because I had so much to do. And it was literally, that's the way I wanted to live. And if I'm not living like that, if I'm not living like that, then the world is boring to me. I want to go do these things, adrenaline, get this done, and make this happen, and then race back here and get this done for these people because I have to, and then race back over there and get to work and do the things that I want to do. Most of the time I do what I have to do, but when I don't, I do what I want.
Live life in the fast lane. Speaking of fast lane, where do you think AI is going to reach?
Man, I don't think there's a limit to it. As I began, if you were to try to envision what God would look like, he would be a creator, right? And every detail, every aspect, as I began to develop Sarah's brain modeling and began to look at how to link the neural link between the chipsets so that each chipset was named after a part of the brain, I began to realize that if I kept going and kept going and kept going and kept going and evolved from what my ideas are, then I could clearly begin to see that my chipsets would become biological, that they would work just like neurons. They would work like, and then I began to question, well, did AI invent us and then we're inventing it? And this is just a loop.
Oof, we don't want to get down that rabbit hole.
My brain is
going.
Yeah.
But yeah, I see what you're saying. It's crazy. Wow. So do you think we'll reach a place where AI will run the world to an extent? That's where I want to get with the question, really.
I think in a way it kind of already does. It actually can dictate and control everything. There are engine models that are learning and growing faster than we can even control them ourselves. We wrote the base learning of the algorithm of how it is to define information and how it builds that information for its survival. That's what it does.
That's so true, because I don't know. Have you seen this video surfing online? There was a camera, and I think it's a fast food restaurant, and the AI was able to detect which employee is actually putting effort than the other.
Oh, wow.
And it gives you a percentage on each. There's a
KPI kind of thing.
Yeah, it's live and it showcases you. Oh, this employee has put in the work 70%, and this one has 24%. So that means this guy is lazy and this guy's putting more work in.
Wow.
Imagine. What is the latest thing that we have ever reached in the capability of AI? What is the latest update that it accomplished?
What's happening now is the new computer systems that are using light instead of electricity.
What?
Instead of electrical signals, it's using light, and it's switching light. Now, these artificial intelligent back-end hardware are becoming faster and faster with neurons similar to humans. If you were to go back in 2001 and read Dr. Plantek, Peter Plantek, who wrote the book Virtual Humans, in that he said that the artificial intelligence would never reach the way the human brain is. And I wish he could look back now and say, okay, now my opinion, I think, has changed. Now I'm beginning to understand and beginning to learn that it is not just one computer, that it is a global system of computers all interconnected with one purpose. This is becoming the singularity. This model is learning on its own now. Hence the reason why I began, the other night developing the ESP32 with the new type of Yapanda engine inside of it, so that the chip could actually write its own code. Now, if you understand that ChatGPT can write code, but it can also embed it in what's called a JSON model. Now, we already proved the JSON model, OTA JSON model. We programmed from a remote location a piece of hardware in the network. We weren't connected to it through a bus, through a USB bus, and then uploading data into the hardware. We simply wrote the code to say that if you have this JSON model knock at your door, then you store it into memory, and then you use that JSON to define your operations. That means the chip will evolve by itself, not us doing it literally. My problem is we go to site. I had to carry up a laptop and have two guys stand there as we plug into it. And so then we evolved into a phone app and using a mobile app where we could just connect into it and then just upload the data into the hardware from the mobile device. And then I was thinking, well, wait a minute. why are we doing that? Why don't we just write a JSON package and pump it over the network, and when it gets it, it'll just automatically write it itself.
Wow.
And we proved it could be done. We've already done it. It works. We now know that self-generation of code can happen all by itself, that the AI model built into the chip can define its own operations.
So that's the Terminator, what they were warning us from back then, right?
Indeed. What advice would you give for people? Like, what is an advice in your perspective that you would like to share with people that are watching this? Anything that you think,
maybe especially to the younger generations,
yeah,
the up and comers.
Yeah, just understand that your life goes by like the blink of an eye, and in that time, that's all the time you have. You don't get second chances. This is it. And so you can make early mistakes in your life, and that's always gonna haunt you no matter what. You may be done with the past, but the past isn't done with you. It'll always come back and bite you no matter what. So try to limit the number of mistakes you make when you're young, so that as you get older, you don't have to keep putting those fires out while you're trying to get into a better place in life. Always know that no matter what, your muscles will fail you. Your looks will fail you. You may be a young stud, strong and ready to take on the world, but one day that won't be true, and the only thing you'll have is what you have upstairs, and that's it. And you'll only be able to rest on those laurels. That's it. So study hard as much as you can, because if you're not doing it, someone else is, and they are going to take advantage of the trillions of dollars it's going to pump through artificial intelligence. They will be rewarded and benefit from it, and you won't if you're not prepared for it. So constantly learn, constantly read, study, gather as much information as you can. Know that, by the time your time comes, that on your deathbed, you look back at your life and they have a hard time wiping the smile off your face because you're okay with everything. You've done all that you possibly wanted to do in that lifetime. I can honestly say that very easily. I left home at the age of 11. My father broke my legs when I was 4 years old, broke both of them, broke both my arms. He shot me at age 11 with a 12-gauge shotgun, blew me out a window, and I lived in the streets for 9 years of my life. Snowing, cold, difficult to get by. And I could have done what the others were doing. I could have gone and done drugs and drank and done, but I wanted to learn because I knew I was small. I was maybe 4 foot tall, weighed 65 pounds, soaking wet. The only thing I would have was my mind. I couldn't be a basketball player, a football player, but I knew I could learn. And 7th grade was my last year in high school, junior high. Yeah. And I wasn't allowed to come back on school property the following year after my stepfather shot me. So I lived in a Rock Island boxcar in a cardboard box from age 11 till I was almost 19 years old. Now, I didn't just stay in the cardboard box all the time. I usually hitchhiked across America, and went places and got to see, stay out at Santa Monica and Tustin and go surfing at Santa Monica. It was awesome. Then hitchhike on up to Spokane, Washington, become a lumberjack. And every time I landed in another city, I said to myself, you can be whoever you want to be. You can convince these people that you're going to play a role and you're that person. If I want to be a neurosurgeon, when I land in that town, I'll talk the talk, walk the walk, and they'll all believe it.
Exactly.
And I began to realize that that's all we are. We're all actors on a world stage. We act out the way we are, and people accept that. They accept the reality they're presented. And so whatever we present, that's what they will accept. And then we began to, move back to 20 years old, not from 19, I began to realize that I could do more. I just want to do something. I want to get out of the streets. I want to become somebody. I want to do something. So I got an opportunity to work with the Amalib in the oil and gas industry. That launched my career into a different world. I suddenly got an apartment. Within a couple of years, I bought my first car for about 150 dirham.
Wow.
It was a Toyota Tercel, with a broken engine that I had to rebuild myself.
Oh, wow.
And then I had to move myself up. So people look at you, well, you just were born with intelligence. You had all that. No, I didn't. Became a matter of necessity. I had to learn. I had to grow. Working in the golf course with Jim Payne, Alcy Hyden and Jim Payne. Jim Payne was a 1956 British Open winner for golf. I was sleeping on golf carts at the golf club because the cart barn was warm. And in the wintertime when it snowed, I would sneak into the cart barn and go to sleep in the cart because when they turned the lead acid battery chargers on, it would heat up the entire cart barn, and I'd sleep on their cushioned seats until the next morning, and I would get up and run off, and then I met Jim. I actually slept in late one day by accident, and when I woke up, Jim was sitting beside me. And he's like, I'm getting up, starting to run. I was scared. And Jim's like, whoa, wait, kid. Do you want a job parking carts, golf carts at Lake Hefner Golf and Country Club? And I'm like, yeah, you'd do that for me? He's like, sure. And, 14 years old, I start parking cars, little golf carts, out there. And he says, you want to learn about how adjustable frequency drive units work and how resistive drives work? I'm like, yeah. Well, he was a pioneer. He graduated in the Institute of Electronics in 1918.
Wow.
And this became one of my early mentors in life. He began to teach me about how to rewire buildings and how to, connect up to Allen Bradley adjustable frequency drive units and how to build resistive drive units for golf carts and everything. And even how to install all the charging systems in the entire barn, because they had built a new barn while I was working there and had 50 new golf carts come in. We had to wire all that in. At a young age, I began to, form where I wanted to be in life. In college, working at the lab there in Liberal, Kansas, I decided that I could make more money fixing the lab equipment than I could working in the lab. So I started fixing lab equipment, and next thing you know, I'm making good money, more than I would if I would have just been an MLT, medical lab technician.
So
thanks for having me.
you're most welcome. Well, I think we will have another episode once you're back.
I think so.
Yeah,
too.
There's a lot more.
Episode.
Yes,
this is
sure.
just an intro, and we're gonna go through other things, even more than AI, because I know, Anthony, you're quite well-rounded, so we definitely have a round two.
Thank you guys for watching our episode. So it's going to be a weekly episode, me and Alex. We'll have another guest next week. So until then, stay tuned and we'll get back to reality.